Welcome back to week 6, and we'll talk about, in our last video, cyclones, what they are and how they form. What are they? They are an area of low pressure around which air flows counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Two main types we're going to talk about in this class are mid-latitude cyclones and hurricanes, or tropical cyclones, another name for those. And here you can see images of each of those. Top image here is a mid-latitude cyclone. We're going to talk about the development of these in the next 3 slides. And then down here we see a hurricane about to strike Florida. So the mid-latitude cyclone development is described in this Norwegian cyclone model. You can link to the website that this information was gathered from on the course website. The Norwegian cyclone model was named in honor of a Norwegian meteorologist who came up with this idea of mid-latitude cyclone life cycle. And this starts with initially a boundary or a front that separates 2 different air masses, warm from cold. And the front is often stationary at first. We move into stage 2 and we see a wave starting to develop, or a kink. Either way you think about it. We see precipitation starting to develop because we're starting to have these actual fronts developing. So we see a cold front on one side and a warm front on the other, and a low pressure system starting. So we start to have air rising as a result of the low pressure and also of air being forced up and over these different air masses. In step 3, that wave or kink intensifies even more, and we see organization of each of these different air masses and fronts. So we see a nice solid air mass in front, cold air on one side, warm air, and then cool air. And then if we move forward again, another time step, that wave becomes even more developed. We see a mature low pressure system with a cold front that is rapidly catching up to that warm front on the other side, producing an occluded front that you see here. And then if we continue to have this cool air mass and warm front moving faster than that warm front, we end up overtaking and making that occluded front even larger and having a much higher developed pressure system. And then after this stage, once we end up totally overtaking that warm front with that cold front, we end up having that supply of warm, moist air being cut off, and that pressure system is going to start to dissipate as a result. So this is that life cycle. So it starts to develop, gets stronger and stronger, and then finally kind of dies off as a result of its own force. And here in the next slide here, we can see kind of a stage 4-5 cyclone that has developed in New York area. It would be about here, Great Lakes up here. So this cyclone here, you can see the precip patterns developed along that front, so we could trace that occluded front all the way through here. So pretty well developed comma shapes that we see in those mid-latitude areas. So this would be a mature stage, occluded front, and it's starting to lose its strength. So it ends up breaking down after this point, which is pretty cool. The next type of cyclones are tropical cyclones, hurricanes. Depending on where you are, each of these have different names. If you're in the Atlantic or Eastern Pacific, we call them hurricanes. Western Pacific, typhoons. And in the Indian Ocean, they're called cyclones. All basically the same thing. So this is organized circulation with winds that can exceed 74 miles per hour. Sustained winds, so pretty gnarly storm. This top image that you see the kind of red patterns, we see the development of those cyclones and then the path that they travel. Kind of a hook shape here on the east coast, and then on the west coast we see it kind of traveling out into the Pacific. So typical structure, you can see in this diagram here, is an eye in the center, eye wall around that clear center, and then rain bands all around. So air near the surface spirals in and rotates counterclockwise, if we're in the northern hemisphere again. Around that storm center, that air is rising in that eye wall, so we end up with lots and lots of precip in the eye wall. In the very center, we have air sinking, producing that clear spot in the very middle. And then we have these alternating bands as you move outwards. So we see pretty massive cloud cover with these cyclones. So where do these form? They tend to form in warm water. They need warm water to develop. So they're going to be over tropical oceans. They rarely form within 5 degrees latitude of the equator because the Coriolis force is weak. It's almost near zero, and so these clusters don't rotate that close to the equator, so they're not going to develop there. They also won't cross over because if you're in the northern hemisphere, all those winds are going to be diverted to the right, and in the southern hemisphere to the left, they're going to be diverging away from the equator. So the major regions here you can see in different colors. The light green is the Atlantic Basin, where we see a lot of the hurricanes that hit the United States. We see the Northeast Pacific Basin in yellow, very rare occurrence there, not as many, smaller zone and no landmass for them to strike. We also see the orange area, so maybe some of those storms might make it across the Pacific and hit places on the opposite side of the Pacific, over in China and Japan. Would be the orange area. The pink area is the North Indian Basin, another small area. Southwest Indian Basin is going to be purple. Blue is the Southeast Indian Australian Basin, and then the green is the Australian Southwest Pacific, so the darker green. So these are all the main zones where these cyclones, these tropical cyclones, will develop. They'll start to form, they'll get really large, and then they'll dissipate within each of these zones. So some of the contributing factors here, we need to have warm, moist air and oceans to supply moisture to this storm. So once these storms cross over onto land, they're going to start to weaken. And as that low pressure system keeps this runaway evaporation cycle developing, we see this storm getting more and more developed and more strong and bigger as a result. So we see as that air rises and condenses, we see precipitation in clouds and condensation. Sometimes that condensation heat is released, warming the atmosphere, and the air can actually rise even further to develop this much larger storm. So we're going to talk in more detail about storm systems like hurricanes in the next few weeks. So that wraps up weather systems and the major types. We'll see you next week.